Good afternoon, everyone. I hope you guys had a great spring break. So we had an exam last week, and then I haven't taken the time to grade them yet. I'll be grading them later on today. Oh no, it's still due, right? It's due tonight. Then I'll go over them later on, or tomorrow night. Can everybody hear me? Let me check my speaker for everybody. Okay, give me one moment. Let's give everybody a chance to come in. One little moment, okay? Let's see what happened. For some reason today I thought nobody was there, so I said, where's everybody? Okay, so one moment, okay? I'm sorry, I'm talking and my phone, my computer is, I put on myself on mute. So again, let's talk about what we talked before we went into the break. And now last week we had an exam, and then it was extended until tonight. But make sure that you don't miss class, okay? We're talking about some stuff related to population, a proportion, all of these things like that. So let's go over them a bit so we can remember, and then we can keep going to the class, okay? So let me share my screen with you. All right, so let me just start the screen first. If you do the slideshow. From the beginning. Give me 1 moment, okay? So from the beginning, and then share the screen. Okay. All right, then, so let me make sure that I have this one open so I can get everybody in. 1 moment. My chat is on. So make sure you can see what make sure you can see what I'm talking about. Give me 1 moment again. 1 more moment. Subtitle. Now I got a bigger screen. Okay. And remember that we spoke about something called population, and then also for the population, it's like a big giant thing. That's going to be the population. Okay. Inside of a population, we're gonna take something called a sample. Population. Okay, inside of that, from the population, you're gonna take a lot of sample, okay, randomly, and then that'll be a sample right here. So make it bigger for you so you can see, that's a sample. Okay, for the population, so this is what we're gonna be studying. We're gonna set a big population. And then hold on, give me 1 minute. I'm trying to answer somebody. Okay, so from the population, we can then we have parameters. Okay, the parameter that we use for populations, we say that it's going to be, this is the symbol that we use for it. Whenever we talk about parameter, we use that symbol mu. Okay, if you talk about the mean, okay, so this is a numerical value that characterize some aspect of the population. So for it's a parameter, we use the mean mu. Okay, if it's for proportion, we use the symbol p. Okay, this is still parameter for the population. And then if you're talking about something called standard deviation, which we talked about before, we use the symbol sigma, if you remember. So all these are characteristic of the population. Okay, but if you talk about the sample now, give me 1 moment. So to get those, you need to do a census. All right, so you're gonna select everybody from the population. If I ask you to do a study right now, it might be hard for you to do a census, okay? Because you have to go and select every single person of a population, okay? But it's what you can do if I ask you to do a study is to do a sample, okay? You can select a random sample from the population, random sample. Like if you're talking about all the students at TCC, you can just select some people on like a few people walking down, going to the library or walking down the hall and so on. You can just select anybody. That would be a sample for you. Okay. So for the characteristic for the sample, we use something called statistics. Okay. For statistic, we do have something called if we talk about the mean, we use the symbol X bar, right? If you talk about the proportion, so about my R, I do have problems do my R proportion. Let's put it like this, Proportion, we use the letter P, and then it's the expression on top of it, okay? We say P hat, right? That's what I did before. And then if you talk about standard deviation, we use the symbol, letter symbol S, okay? S for standard deviation. We say that they are an estimator. They are, I mean, in fact, we like to say this is the best estimator. What that means that X bar is the best estimator for the mean mu. Okay, P hat is the best estimator for the proportion P, etc. You can do the same thing for sigma and S. Okay. Any questions so far? I know probably you guys watched it from the. Okay, no questions. Okay, from the spring break and the exam. So whenever you got these things, you're gonna do something called statistical inference. I mean, you're gonna make some conclusions. You're gonna make inferences. You're gonna deduct something. For example, if I say I'm from the island, okay, and then I'm being rude to you, okay. Each time I'm being rude to you, see me, I'm being rude to you. And then you're gonna say everybody from that specific island is rude. And then you make a conclusion based on what, I mean, I'm being rude to you, and each time you meet somebody from that same island and they seem being rude to you. So you're gonna assume that everybody from that island is rude. You didn't have to go to that specific island and interview every single member, but from the interaction that you have with the few people that you have here in the United States, then you can conclude that everybody is rude. Okay, that's quite what you do, an inference. Okay, you deduct something out of what you've been going through right now. You make a conclusion. So I conclude that these people are rude. Okay, based on the small inference that you have so many people here around here. Okay, so that's what I'm going to be doing with statistics. So everything that we do in the statistic term, you're going to have to make a conclusion based on the population. Okay, based on the sample, you're going to make a conclusion about the population. Okay, so hold on, I think I lost my cursor here. Okay, so with that, it does involve uncertainty. Okay, so it just allows you to read about it. I mean, just because you make an inference doesn't mean you have to be 100% correct. Okay, that's mean we have room for error. Remember, we always have room for error. So it's not 100%. Now your conclusion cannot be 100%. Okay. This is a quick idea of a population. Suppose here, he asks about 1,000 US college students if they prefer to study alone or with other people, okay? The population is all US college students. That means the entire population, if you're talking about population, you're gonna have to do a census. For that census, you will deduct mu, P, but here we're talking about what? Let's see. It's about proportion? Yeah. Down, okay. They said the sample is 1,000 because you select that 1,000 students from all the college of the United States. Suppose the big, huge population will be all the college of the United States. All college students of the United States. That will be this one. Then you take a small sample out of it, and then you study it. The sample that you study is about 1,000 people. Okay, and it's about 1,000 people that you survey. Okay, out of those 1,000 people, some of them say they prefer to study alone. Okay, so here we have a parameter P that this is going to be the parameter P is for the population. You're gonna study the sample, but the sample will give you an idea. You're gonna study the sample is going to of the population. Okay, so here we're talking about you see we're talking about the parameter still. But we're gonna talk about this one soon. But right now we're talking about P. This is what we want. This is the one that we want to talk about. We want to talk about P. So we're gonna say what proportion of the population like to study alone. Okay. So we do have a P, let the statistical be P hat. Okay. This is the proportion of the 1,000 students who study alone. Okay. So what do we say about this one? It means that, remember that P hat, let me say my cursor, P hat, it tried to define P. So for my little sample, for my interaction with the 1,000 people, okay, I can say that about 42% of all US college students prefer to study alone. I didn't go and ask everybody to do it. Okay, I just lost somebody here. I didn't ask everybody in US college. I didn't go and ask everybody, but I asked 1,000 people who are in college. And then from that little sample, I got an idea of the entire population. I got an idea of all US college students, okay? So that's why I say the PIAT is trying to get an idea of the population. It doesn't have to be exact. It can be off, it can have error, okay? But you get an idea anyway. That way you can make conclusions, okay? So let's see, oopsie. Where's my cursor again? I was trying to get somebody in and I lost the cursor, okay, right. Then there'll be bias, okay? And so whenever you do stuff, make sure whenever you do study, suppose I ask you, hey, listen, go ask some people whether they prefer to be Republican or Democrats or something like that. Okay, so if you select things that benefit you the most, then it's gonna be biased. Okay, a study that's biased is not good. Okay, it doesn't really represent the population. You don't want something like that. Okay, so don't choose something that is convenient to you whenever you're gonna do you're gonna select a population, and then it's not gonna put it the right answer that you're looking for. Okay, I mean that probably that you are looking for, but not that the study is looking for. Okay, suppose I'm a Republican, and I know all of my family know that I'm a Republican, for example. I'm gonna ask everybody of my family, do you prefer to be a Republican or Democrat, something like that. So of course, people are gonna tend to love, I mean, because they know me, they're gonna try to. So here are some way to avoid being, whenever you do study, suppose I ask you to go and do some research and do a study. These are questions you can ask yourself. Hold on. You can say, for example, because we were talking about proportion, right, of population. You can say what percent of population, what percent of people who were asked to participate actually did so. Okay, you can ask this kind of question. What the person who really did it. Okay. You can also say, did the researchers choose people to participate in the survey, or did the people themselves choose to participate? Okay, that's what I was talking earlier. You're gonna select your own people, yeah, and that's gonna support you. You know, to say, but you didn't select really everybody, because you don't want people to get against you, something like that. Okay. We can also say that the researcher leave out whole segment of the population who are likely to answer the question differently from the rest of the population. Suppose I'm doing a survey, a political survey, and I know these people are on there, they support this guy. So I'm not gonna ask them because I know they're gonna make my study look bad. So I'm gonna ask these people over there because they support my ideas, they know what I like, and I got 1,000 people over there that will support my idea. So So you have to be careful whenever you do your research, and then we're gonna select your sample. It has to be unbiased, okay? Without any, you don't put your emotion on it. Make sure that it's objective study. Even the statistics are not the exact science, but we have to we have to look for the truth at all time, okay? And here, this one say, we want to know, we're talking about all Americans, right? This is I'm going and ask all of our 2,500 friends on Facebook whether they prefer Twitter or Facebook. That's a problem here, because here, friend on Facebook doesn't have to be only in the United States. Okay, some also, I mean, it doesn't have to be in the United States only. 2,500 friends on Facebook, but we say the population is all Americans. Here we have a problem with the population I choose. It has to be the exact population. You have to make sure that the population you're talking about are really in the United States. Okay, that's one factor. All right, and also here, this one say, a researcher asks 500 randomly selected people, are you in favor of the unfair tax burden that the hardworking, successful business people have, so that the lazy and unemployed can receive a paycheck without working? Okay, so if I want to say are you favor, so we don't really see that much here, that part here, but because it's a random, we can let it slide a bit. But you see, but there's an idea and beyond that. Some people might say, oh, this guy said I'm lazy, something like that. So, and then you might want to go people that are working only. Okay, so you don't want to ask everybody. That's the thing going on here. This one say, on July 4th, CNN posts on their website a question asking if they support the current US limited operation. So about 18,943 people respond. So that survey was posted on the website. Might say that, you know, if you're already on the website, probably you can say, oh, most people would like to go to watch the website, stuff like that. They're gonna, you know, if you see anything, gonna go into send all the time, so you're gonna answer, and then you're gonna probably believe what they say. So that's something going on here, because you wanna say, what if they didn't post it in the website? They post in a different location. What if they post it in the local newspaper, something like that? So there's still question going on in that part. All right. So we need to you have to make sure whenever you select your sample, it has to be close to fairness. Okay. Here, this one say, 101 of the selected Americans were asked by a researcher, do you currently have a sexually transmitted disease? This one say 100 selected American. It does. Here we can see that there is no bias here. 100, and I think it can be any American, any person, anybody, but it's just 100 people. I think this kind of like say that is not biased. Okay, so there's no idea beyond that. That is biased. Okay, this one saying, got up on a contact and phone number from the yellow page and call if they call to ask if they support government funding or high-speed rail. I think that's pretty fair. It just one person when them selected phone number, it didn't say the one that is close to home, they didn't say something like that. They say just you open it and just select 1,000 random people. Okay. And then someone, I think I'm gonna let this one for you to read. On the side, let's see what can I let you read also. Oh, this one is important. Remember what I say, whenever you select a sample, it has to be random. Okay. It's not something that is, you have no perceived idea behind your head. It has to be completely random. That's why that idea we're talking about here, it has to be random, okay? So this for you can just read anytime about that. Oh, sorry. Let's see. We do have in stock on some way to select random idea, but we're just gonna assume it's correct, and then we're gonna, like here we got a 4 people right here. You don't have to use scan profile. You can just bind it. So you can select this. So this is a sample. Assume this is a population here. Okay, and now on a sample. a sample, here the population here has at 4 people on it. Some population. Assuming, that's an assumption. This is the entire universe. Your entire population, and for the population, you have about 4 people, right? So if you want to select a random of n, you can use sample to help you out, but also you can just say, I can select my first person as Miguel. Okay, no. This is using StatCrunch, but I'm not gonna use that right now. But I'll show you the next page. Here, this is what happened. You can just, when I'm selected, you can select Anna, Jen, Miguel as an example. This is a 2A sample. As you can see, this is selected from that, nothing else. It's selected from the population, and it's equal a sample. It can be anything else. Somebody else might select Emily, Joe, and Anna, okay? And somebody else might select Jen, Joe, and Miguel, etc. All right? But this is that sample is taken from the population. All right? Any questions so far? I see a no there, but that's 543. Any questions? Okay. Let me see. Okay, so I think whenever you talk about, this is an idea, whenever you select a population, and there's idea of accuracy, of precision. Here, do we have an example of something that is both precise and accurate? That's a picture. Over there, you have a picture of that is precise, but not accurate. Over there, you have an idea of something that is accurate, but not precise. And over there, we have an idea that is neither, okay? So what we wanna do, to the best of our knowledge, is to get through this, okay? We want to be accurate and precise as much as possible. Okay, just because you want to be accurate, there'll be some room from error, because we're not 100%. There'll be some room from error for error as well. Let's we talked about bias before, so I'm gonna skip this part right here. From the sample here, this is Mike, Rick, Sue, and Mary. This is supposed to be the what do you call it again? This is supposed to be the population. Okay, assume this is the population. Okay, an entire population. Okay, population. Okay, here. Okay, this is an entire population. So they say probability to select a male is 40%. If you see that this is a male, Rick, Mike, Rick, and then all of the rest are female. That means you can do, that's gonna be two out of 5 people are males. Okay, which give you 40%. Okay, 2 out of 5 people are males. Now what I'm gonna be doing is gonna build some other samples to see what happened. Remember, it can be accurate. We want to be accurate and as much as possible. Okay, suppose when I do my sample, my first sample, okay, and I select week, Sue, and Rose. So notice that the person of male, and this one will be something like this. As you can see, only in this sample, only week is a male, right? That means this is going to be 1 out of 3. Now the sample here is 3, right? So how far I'm off? This is 32%. Okay, so how far are you a little bit off here? So the other one is 40%. If we do difference, okay, that'll be let's see. This is for the poor person is 40%. How far are you off? So let's do, don't know about the sign yet. So okay, let's put that way. Let's put overestimate. Okay. So let's take a second group of people. You take Mike, Rick, and Rose. Here, your proportion becomes 67%. So you're going to do 67. And then in that case, we have 2 out of 3. So 67% take away 40%. So what we have here, the difference would be about 27%. So here you overestimate by some number. Okay, so this is like, let me just fix that. I was trying to get somebody in, and I just. %40. That will be about 27%, but this is above. This is here, you overestimate. Okay, these are the error I'm talking about. The next one here is you like Sue, Mary, and Rose. In that case here, we have no male. Okay, that'd be 0. 0 out of 3 are male. It can happen. That means this is here, we completely off. Okay. So here, you can select any sample that you want. It can happen that you select a Sue, Mary, and Rose, and there's no male on it. The proportion is 0%. But remember that from the original population, it was 40%. Okay, so it's depending on the way you select your population. Okay, but we want it to be precise and accurate as much as possible. But sometimes we're gonna have some error. We're gonna run into error because nothing is 100%. Okay, we're gonna end up into some error as well. Okay, nothing is 100%. Let's do a quick go for what you just did. Here, hold on, let me see. So this is the same picture I taken earlier. Here we have a no male, that'll be 0% and 32% and then 67%. That's the idea. I will show just a bit as a graph. Okay, but for the mean, you want it to be 40%. Okay, but you can see that the correlation of all sample population equal the population proportion of 40%. We still off, but we want to assume that even though it's like this, P hat, okay, is the best estimator for P anyway. The reason why I say that is because you're trying to express the population proportion while using the sample proportion, okay? And then you just kind of got an idea. There should be room for error. The error can be big, small, okay, or can also be extremely small, whatever it is. Okay, that's the idea behind that. All right, then I'm gonna skip this one for you. Just gonna go and read that part. And note, and I would like to talk about the errors a little bit quickly. Let me just skip those. I'm gonna skip this part right here. This is the same idea. Let's go keep this one. Skip this one. We can, if you have time, we'll come back to it. Okay. Let's talk about this one here. We talk about a population proportion here. Here, in the case of a population proportion, okay, let's put proportion right here. Let's talk about the error. Proportion. Okay, for proportion, with the symbol that we use is the mu p hat. You see that letter p hat, that means this comes from the proportion. This is equal to p. We're trying to define p. Here, we also have something called the standard deviation of p hat. And this is the formula they use for it. Okay. Let me just remind you quickly. If you're talking about the mean, which I'm going to go over it soon, you got something like this. So I don't want you confused. If you're talking about the mean, you will have something like this. You can say mu x bar is equal, oops, sorry, let me just fix that. little thing. Mu x bar is equal to mu. And then it'll be sigma, which is the standard error, x bar is equal to sigma. Okay, then I will talk about the formula after, not now, okay? But just to remind you, here we're talking about proportion. For proportion, we have mu p hat is equal to p, okay? And then sigma p hat is equal to sigma, okay? And then these are the formula we have. These are the standard error, all right? Any questions so far about that? This formula, I want you to write it down on your little cheat sheet, okay? So you're gonna write it down. There'll be a bunch of, again, there'll be a bunch of formula. It's gonna be hard for you to remember. They have to write them in the cheat sheet. So this one, I need to write it down. So remember, okay? There'll be a different variation for the sigma. Here is the sigma is not given to you. I'll give it to you later on. Here, the sigma here is at 1 square root of p 1 minus p over n. Okay, I'll give you this one. I'll give you the one for the mean later on as we advance in the class. Okay, so let's put some notes on that. See, you said the mean of the sample distribution is equal to the population mean. The mean of the sample distribution is equal to the population proportion. And then if the sample size is increased by a factor, then the standard error will be decreased by the square root of that factor. Okay, here this n is the sample size. If we increase, then this one will decrease. Okay, sigma will decrease. How can I put that here? This one will decrease. Okay, the reason why is because it equals at the bottom. This one increase. So that means if you have a huge sample size, like the US is like entire population of US, something like so huge sample size, then your standard deviation should be smaller. Okay, your standard deviation should be smaller. That's what the idea. I think that's one of the question of one of our tests, like probably test number 1. Okay. Also, so we come back to that one again. Any questions so far? Any questions? Okay, I have somebody in the room. One moment. Okay, no questions. All right, then. So I'm gonna have a question for you then, if nobody have questions. So let's do this one more time. You see, okay. Here again, this is an example. This one says only 65% of insured women get annual pap tests. Find the mean is an error for the sampling distribution with sample of 500. Are you guys able to get me the mean and standard error? Go ahead. Using the formula I will give you, can you guys get me the mean? Here, because talking about proportion, here. So here, this is the mean, is the proportion p, is proportion p hat. So we need to find, and when I'm in find the mean here, okay, I know I'm talking about this specific term here. Okay, but in fact, what I want, because of the specific term, I want p hat. What will be p hat? And what will be sigma, the standard error sigma p hat, using the formula we have over here. And also remember that p hat is the best estimator for p. Okay, go ahead. I'll give you 5 minutes to think about it. Find p hat and find p, sigma p hat. I'm going to mute myself for 5 minutes, okay? Until you guys work it out. You can always also type the answer in the chat, okay? Yeah, that's what I did. It should be easier for now to answer the question. So what will be the question for, what will be the answer for that? Marilu? What's the answer for the proportion? Very good. Okay, so you have to make sure you get it. So that'll be 65%. Okay, and what would be the standard deviation, I mean the standard error? Okay, very good. All right, perfect. So essentially got this one. We have to remember that this is a very important formula whenever to count proportion. Okay, so this p hat, I know you see here you don't say p hat right here. Okay, but this is for the population. Okay, and then you have the p hat here as 65% as a p hat. This is the best estimator for the proportion population, and you got sigma hat. All right, perfect. Now, a couple of things you to remember with that sometimes p hat can be unknown. If it's unknown, sometimes you just can assume that it's close to the population. Okay, it can be unknown. And then what you need to do, you can just use the one from the sample here, right here. So if the P is unknown, that's how I'm gonna say P. I see P is unknown. Instead of using P and the population, you can just use also P hat. That's the same thing. Okay. All right. So it may happen that the P can be unknown. All right, then. So let's keep working. Any question about that? Any question about that? Okay, perfect. Now, this is something we just say earlier. Remember what I said earlier? If the sample size is big, then the standard deviation is smaller. As you can see here, we have n is equal to 100, right? N is equal to 100. That's a huge sample size. You see how close each of them are to each other? They're very close to each other. Compared to the one that is n is equal to 10, the distance between each one of them is bigger. See that? That's a huge distance compared to this one, which is kind of smaller. And then you take a smaller one, which is 5. And then the distance is again way bigger. Usually, whenever something is like close to 30, okay, we can just by 30 kind of start getting the shape that we were looking for. You know that bear shape we're talking about? Also, the distance between the elements also kind of like start getting into place. Like 30 be like a magic number. Okay, it's like a magic number. All right. So that's a visual presentation of what I wanted to talk to you about earlier. One thing also. Let me just keep working. There's something called a central limit theorem, the central limit. So this is, in this case, this is what happened. You want to make sure that whenever you do your selection, it has to be random, okay, and independent, okay? I know the time independent, we talked about it before in the past, okay? But the idea is the same. Think about random, okay? And then whenever I do the try, if you do something that somebody asks a question, let me see. All right, somebody has a question. Give me a moment. Okay, I'll give me 1 moment, okay? All right, then. So we do have a way to know if it's correct or not. A sample size is assumed to be large if it's at least 10. If you have the samples as at least 10 successes. So the way you do it, you do NP, you multiply the sample size times the proportion. It has to be greater or equal to 10, okay? Or at least 10 failure, and at least 10 failure. Also N, 1 minus P is also greater or equal than 10, okay? So this is when something is assumed to be large. Let's recap a little bit what we're talking about earlier. We said that if the sample size is small, the elements are not close to each other. Here, as you can see, we don't really have that bell shape that we're talking about. But if the sample size is big, like 100 or 1000, we have the elements are very close to each other. And then we can start having that bell shape. And also notice that whenever you're talking about that magical number 30, it kind of like got that nice bell shape that we're talking about here. So having that nice bell shape, okay? So you want that bell shape to continue with this statistic class, okay? So here, we're talking about that idea. We want something to be large. Whenever something is large, if the sample size times P is greater than 10, okay? Earlier, we had an example in which we did what? No, I'll use an example I have here, okay? So you have to be greater than 10, all right? let's assume, for example, I think we had an example earlier in which n was, let me see. Let's go back to an example in which we had earlier about the voters. I mean, the US students, yes. I think was what we had n is equal to 1,000. And then proportion of people who study by themselves was p hat is equal to 0.42, I believe. No, right? Yeah, that was 0.42. Okay, and here I don't give you p, so I'm going to assume that this is p hat. So what I'll do, let's see. And what is 1 minus p? 1 minus p is like what you call the we talked about it before, is the probability for p not to happen. We talked about it before whenever you use that symbol, the complement of a, whenever it have to be when or no when or a bar. Okay, in that case, this can be p 1 minus p. Okay, that, like, for example, probability for it to rain today, it'd be 40%. Remember this thing? Suppose it's 40% for rain, and then no rain, this is for rain. No rain would be 100%. Take away 40%, that'll be 80%. I'm sorry, 60%. Or if you want to do and using decimal, for probably for no one, it'd be 0.4. This is previous class, right? I don't know if you guys, I know you guys remember that. Then you're gonna do 1 minus 0.4. That's going to be 0.6. So to have no rain. Okay, so remember this thing. We'll review those notes. Review that. Review. Okay, give me 1 moment. That thing we just messed up again. Go and review this little part here. Okay. Review. Review complement. We talk about whenever talk about probability. Okay. So now, so what I'm going to be doing, I'm going to do, you say NP must be greater than 10. So I'm going to ask me the simple size. As you can see, N is not 1,000. So whenever it's, whenever it's more than 30, it's already something. But this is like N is 1,000. That means already big. Let's see anyway. Let's double check. So I'm going to be doing, going to be 1,000 times 0.42. So I might just give you. Anybody use a calculator to get me the answer? So I might just give you 1,000 by 142. How much is that? Thank you. That's going to give you 420, which is way bigger than 10. So now, if it's bigger than 10, then it's going to be assumed to be a large sample. Okay, it has to be way bigger than 10. It's going to be large sample. So use that as a guide. Okay, so this is as a guide. And also do the same thing for the Q. Here, the Q will be, you put Q hat, 1 minus 0.42, in which we don't have that. That's going to give you 0.38. No. 58. Okay. Then you're going to do the same thing. You're going to do 0.58. 1,000 times 0.58. And this should give you about what? 580, right? And so on. This is way bigger than 10. So that's, remember, that's a formula now. So write it down and write them down in your notes. So this, whenever you have these things here, they're gonna be assumed to be a large sample. Okay, as long as it's bigger than 10. And then we can use the formulas. You guys understand? The sample need to be large. Okay, you understand? I mean necessarily because of what we were talking earlier here. Let me just show it to you. Let's go over here. As you can see here, we want 30 over here, sample size of 30. As you can see, this is that, you got that bear shape, but 10 is a small sample. It doesn't work that well. Okay, and then 5, something like that. Notice that if you do NPY there, that's gonna give you 0.9 times 10, which is gonna give you 9, which is smaller than 10. Okay, so no good. So you cannot use that as a really good sample. Okay, let's do this one over there. This one good. So you're gonna do NP as well. You're gonna do 30 times 0.5. So how much is give you? If you do 30 times 0.5, how much is that? I think it's gonna give you 15, right? So this is bigger than 10. So this is a good sample. Okay, this is good. Okay, and so on. You guys got the idea for the next one. Let's go back. So that's where we are. Well, okay. They say if the sample is collected without replacement, then the population size is at least 10 times the sample size. So you want that. Okay, this is assumed to be large population. Okay. Let's see. So there's something called central limit theorem in which you have something like this. This is normal, and then you got the proportion P, and then there's a standard error. We talked about that before. When something is normal here, and then we have the mean 0, standard deviation is 1. Talk about this is symbol, that means this is normal. That means whenever I say normal, it means that you have that bear shape. Or you can have something like this, or you can say n, the mean is x bar, and then you have the standard deviation s. Or you can say this is for a sample, or you can say n, normal. The mean is mu, standard deviation is sigma, and so on. Okay, in that case, you got p. Okay, this is the some people like to put mu x here, mu p hat. You can say n, mu p hat, comma sigma p hat. Okay, that's another way to say that the mean is p, or the proportion is the proportion is p, and then the standard deviation is that. That's what you're trying to say. Okay, so we're gonna, this is a way to put the information together. Okay, so again, if you don't know p, you can also use p hat. All right, you can also use p hat if you don't know p. Instead of putting p, you can put p hat. All right, any questions so far? Any questions? Any questions? So if you have no question for me, I do have a question for you. Let's see. They give you 200 randomly selected American drivers. They will ask questions, okay? If they text while driving. I know I'm guilty for that too. You say 48 of them admit they did that, okay? Remember, the driver were going to be randomly selected. That's one fact. That's what we're trying to say, okay? So I would like to know whether I can use the formula I did earlier. Anybody can find me that will be NP and also N1 minus P. I would like to check whether these numbers are bigger than 10. If they're bigger than 10, then I can use it. If they're not bigger than 10, then that'll be a problem. I have to do my simple again. Anybody can get me P, NP, and N1 minus P? Again, this is NY here. And over there, this is P hat. Okay. So I would like to know if anybody can get me NP and NP hat and 1 minus P. I'm sorry. This is not NP hat. This is why I put a mistake here. So this is not P. Okay. This is just an X value. It's an X of them. That's a 48 of them saying that. Okay. If they say this because it's X of them, it means that 48 out of 200 do this. That gives you a fraction. You're gonna say 48 out of 200. That's gonna give you P hat, okay, just to help you out. Okay, now you should be able to get me NP and N1 minus P. What is NP? N is 200. I just explain how to find P hat, which is 48 out of 200. That should give you some number. Now I know how to find NP and N1 minus P. Anybody? You can put the answer in the chat. N is 200. Find P hat. If this confused you, we did say that P hat is the best estimator for P. So whatever what it by me, we don't because we don't know P. What you can do, you can always substitute P hat. Okay, you can always do that. Substitute P hat because P is unknown. Okay. Now I give you all of the clues. So can you guys find me NP hat? How much is it? And also N1 minus P hat, how much is that? All right, guys. I'm still waiting. Okay, to the person who find the answers, I will give you, the first one put that answer, I'll be giving 10 points for the exam. 10 points extra credit. That probably will help you to do something. The first person who put it, let's see. So Eli put 152. Let's see what happened. So it's 200 times 48, give you 152. I don't see anything you put there, exactly like that. Okay, so let's see who got it first, the first PI, because you guys didn't put both of them. Let's put 200 times 48. No. So you're going to do 48 divided by 200. That's going to give 0.24, right? That's P hat. I'm going to check who get it first. So he's going to do 200 times 124. So 200 times 124, that's going to give you 48. Okay. Over there, I'm going to say 200. So let's do 1 minus 0.24. 1 minus 0.24. That give 0.76. So 0.76 times 200, that's going to give you 152. So as you can see, both of them are bigger than 10. Okay, let's double check. See, both of them are bigger than 10. For failure is bigger than 10. So we're going to assume that the population is very large. Okay. So let me see you got it right. You got my pen. So Eli got 152 and Marilu got 48. So it was supposed to be 10 points. So both of you got half points. So that'd be 5 points for each. Okay. So Eli got 5 points because the first one voted 152. And then Marilu, you got 5 points too, because you put the second answer. The person put the second answer. Bristol, you got the 0.24, but I didn't ask that question 0.24. We need that, but I didn't need it. For Bristol, I'm gonna be nice to you. I'm just gonna give you 3 points. Okay, just to encourage you, because you just put that. Even though I didn't understand what you put earlier, like 0.96 something, but you put the 0.24, that's pretty good because that's all I need next. Okay, so now the 0.24 here, this is the mean or the proportion, which is going to be 0.24. Okay, right? And after that, this is going to be the, oopsie, I lost my cursor again. That's going to be a standard error. That'll be 0.03. Okay, so this is what we have. If I would like to put the in the regular term, I wanted to put, I will put 0.24 over here. That means the proportion is 0.24. And the standard error, just put a mu p hat instead, and sigma p hat. The standard error will be 0.03 if you want to express it that way. Okay. So get used to that way of writing. All right. Let's see. I do have a couple examples also available. What I'm going to be doing, I'm going to see if I can, no, I cannot just put the notes now. Let's see. It's already 42. I would like to put all the chapters together. I need one certain to do. So let's see. We're going to have to stop here. I'll continue on Thursday. And when I finish the last thing on Thursday, I'll upload the notes for you so you can be them together. All right? Anybody understand the Chinese? I mean, statistics? Yes, no, yes, no. We're gonna stop here. I will see you guys on Thursday to continue the class. Okay, so let me just put my note there. So we're gonna do a couple examples. One of the examples just like that on Thursday, then we're gonna continue. All right. Enjoy the rest of your evening. So if you have a question for me, I'm gonna stop sharing that. If you have a question for me, please stay so I can talk to you. Okay. If you have a question for me, please stay. Don't leave. Let me see. I had a question with Javon Pierre. Oh, Javon just left. I don't see Javon anymore. Okay, anybody want to speak to me? Nobody wants to speak to me. Okay. So I will have to email Javon.
Hello?
Hello, Milo, yes.
Sorry if there's background noise, but I had a question. On the honor log for the exam, it said that we could only have 1 page of notes, but last time we were able to have more. Are we only allowed 1 page of notes for this exam?
The reason why I say for you because you can use a scratch paper.
It says we can have 1 page of notes and 2 pages of scratch paper on the honor log.
Yeah, you should be able to have. That's it. What's this? They say only 1 sheet of notes.
Yeah, it says only 1 sheet of notes on like the additional.
Yeah, because of scratch paper. So you can use scratch paper. You can use 4 pages. I don't think it's gonna be a problem. Okay, because the other would be considered scratch paper.
No, but it says 2 pages of scratch paper, but then like notes, like that we can use notes on the exam.
Yes, you can use notes. Yeah, 1 sheet of notes. That's what I always put, right?
Yeah, it says 1 sheet, but last time we were able to use more. Is it only 1 for this exam?
Don't worry about it. Just they would flag me for it, but I would don't worry about it. Just the way you did last time. I don't want you to miss the exam just because of notes. Okay. Just
Okay.
the same thing that you did last time. I cannot change anything now because it's already start.
Okay.
But use the same way you did the first exam. Use the same concept. Don't change anything. If there's something wrong, they will contact me and I'll fix it because I'm gonna look at the exams. You did it already?
Okay. Yeah. I'm going to do it now.
Okay. So why you thought the last minute to do it, Marilu?
I wanted to make sure that I had a lot of time to do the test review, but I had work all over the weekend. So I chose to do it today.
Okay, so what I'm gonna be doing, I'm gonna try to extend it for everybody, okay, until probably, let's see. And if I can extend the exam on do it to Thursday night.
Okay, thank you. That's good.
Okay, just in case.
Alrighty.
All right then.
Thank you.
Take care. Bye-bye.
Bye.